Okay, first things first, did you read your agenda? Because if you read your agenda, the very first thing is not watching this video. So go read your agenda first and complete what your agenda says. And then come back and watch this video. Okay, so we're in the back of page 1, completing our notes. We can represent the solutions to an inequality by using a number line. So when we have x is greater than 5, that means every number that is greater than 5 is a solution to the inequality. So that means you can pick any number that's larger than 5 and plug it in, and the inequality will be true. For example, 6 is greater than 5. 100 is greater than 5. 3 is not greater than 5, so this one is not true. X is not equal 3. That's not a possibility. So because of this fact, there are an infinite infinite. It's my bad. Because of this fact, there are an infinite amount of numbers that you can plug in for the variable to make the inequality true. So remember, with the equations, there's just one answer. X equals 4. That means 4 is the only answer that works for your equation. For an inequality, if it says x is greater than 5, that means every number greater than 5 is going to work for that inequality. What that does not mean is you pick just one to say that's your answer. You leave it as x is greater than 5. We show this on a number line by using either an open or closed dot on the number in the inequality. So I would put a dot on 5. And then I'm going to use a line with an arrow that's going in the direction of the numbers that we can plug in for our variable. So since it's numbers greater than 5, my arrow would be pointing towards the numbers greater than 5. Now, it says an open or a closed dot. Well, it depends on your symbols. If you have these lines underneath here, that is a less than or equal, or greater than or equal, either of those two symbols. Those have a closed circle. Whereas a less than or a greater than with no equal to, those have an open circle. Now, what's the difference between an open and a closed circle? What does filling in the circle mean in terms of your solution? An open circle means that you can get really, really close to 2, but you can't actually be 2. This one right here is x is greater than 2. So that means 4 would work. 4 is greater than 2. 6 would work. 6 is greater than 2. 2.4 is greater than 2. 2.00001 is greater than 2. But 2 is not greater than 2. So you cannot plug the number in and be true. Whereas with the one below is x is greater than or equal to 2. So 4 still works, and 6 still works, and 2.4 still works, but now 2 also works because 2 is greater than or equal to 2. So that's the difference. An open circle means this number will not actually work, whereas a closed circle means this number can be plugged in for your variable and work. Now, how to graph these. You're going to start with a number line. If you don't already have it numbered, you need to put numbers on it. You need to make sure that your number line is numbered appropriately, meaning smaller numbers on the left and you count up. You do not have to put 0 right here. You do not have to put 0 in the middle. It doesn't matter. What does matter is you pick a number to start with right here, and then you count up. Make sure the number that's in your inequality is towards the middle of your number line. So ideally, you're going to take this 2 and put it somewhere towards the middle. You don't want to put 2 at the end. You want to put it somewhere towards the middle. Your inequality needs to have the variable on the left, meaning variable on the left of your inequality symbol. If the variable is on the right, you need to write everything backwards. So 2 less than x, I need to write everything backwards. X greater than 2. I'm flipping this symbol around because I flipped the entire thing around. Notice how the arrow is pointing towards 2? It's still pointing towards 2. Then you're going to look at your inequality symbol. You're going to determine if you have an open or a closed circle based on your symbol. Remember, if it has the or equal to, it's closed. If it does not, it's open. After that, you're going to place the correct type of circle on the tick mark of the number in the inequality on the number line. And then you're going to determine which numbers can be plugged in for your variable in order to shade. You're going to shade or draw an arrow in that direction. So when I have x is less than or equal to 2, I'm going to put 2 somewhere in the middle. You need to make sure you are counting by a consistent amount. So if I want to count by ones, I'd put 3, 4, 5, 6, 7, 8, and you can do that. If you want to skip a hash mark, you want to count 2, skip 1, and then put 4, and then skip 1, and then put 6. You have to count consistently. You can't skip 1 and then put 4, and then skip 1 and then put 5. That doesn't make sense. You went 2, 4, 5. But I can go 2, 4, 6, 8, skipping 1 in between. Back here, I would go 0 and then -2. And in between each one of these would be, I would have 0, 1, 2, 3, 4, 5, 6. I'm counting in order. Now I'm going to look at my symbol. It has my line underneath. That tells me I should have a closed circle. So on 2, I'm going to go to 2, and I'm going to put a closed circle on that number. That means 2 is included as a solution. Now it says x is less than or equal to 2. So which numbers are less than or equal to 2? Would 0 work or would 4 work? Which one of those is a less than 2 number? 0. So everything over here. So I'm going to shade all the way through to the end of that arrow and put an arrow at the end. There's your solution. And number 2, remember I need the variable on the left. My variable is not on the left, so I need to flip this whole thing around. I'm going to put x. I need to flip my symbol so it's pointing in the opposite direction. It is pointing towards x. It's still pointing towards x. And then -4. I'm going to put -4 somewhere towards the middle. Now I need to make sure I count in order. I need to get bigger this way. This would be -3, and then -2, and then -1, and then 0, and then 1. Whereas this would be -5, -6, -7, -8, and -9. Then I'm going to look at my symbol. It is a less than sign, which is open, because it does not have that line underneath. So on -4, I'm going to put an open circle. Now I want my variable to be less than -4. Where are your less than -4 numbers? Are they over here on the left or on the right? Well, -6 is less than -4. So all of these numbers are my solution. 0 is not less than -4, so I'm not going to shade over here. Try 3 and 4 on your own. Pause the video, try them, and then come back. Now hopefully you notice the number 3, your variable is not on the left. So I need to flip it all around. It's pointing towards 3. It needs to stay pointing towards 3. Then you're going to put your number somewhere in your number line. Make sure 3 is somewhere towards the middle. Then make sure you're counting correctly. So this would be 4, 5, 6, 7, 8, 9. This would be 2, 1, 0, negative 1. You may have numbers on here in different places, but make sure your numbers are counting correctly, going in the correct direction upwards. Okay, if you have it backwards, you've messed up. If you have your 1 and 0 and negative 1 over here, you're wrong. It needs to be going correctly. I'm looking at my symbol. It has the line underneath, which means closed on 3. So look at your graph. Do you have a closed dot on 3? You should. I want x to be greater than or equal to 3. Is 5 greater than or equal to 3? Or is 1 greater than or equal to 3? 5 is all of these numbers. So when you look at yours, you should have a closed dot on 3, and you should be shading towards the bigger numbers. And then your last one that you should have tried on your own, or if you haven't yet, pause the video now and try it. Our variable is on the left, so we're good to just put 0 somewhere towards the middle. Make sure your number line looks something like this, where your negatives are to the left of 0 and your positives are to the right. When you look at your symbol, there's no line underneath. So that means on 0, you need an open circle. We want x to be greater than 0. Over here, our numbers are greater than 0. And there's our graph.